Right.
All right, you guys ready to get started?
No,
Can you guys hear me okay?
Yeah.
So, this is well, first of all, squelch that microphone.
Automaker number one, they were using these, don't have any more in stock, so you need to have it recalibrated.
So first of all, my name is Bill Fredericus. I'm the service manager from Boimer. I was asked to come up and do a refresher training for you guys, which I don't know if it's such a refresher. There's only 2 guys in here from the beginning, but the standard training is usually a week to 2 weeks in a classroom, which is a lot of the manuals that are over there. The refresher training is more of a designed to kind of go through the system from top to bottom, and how things work and how they work together. Because a lot of you guys have already been working on the sorter, have had some experience with the sorter. So it should be more or less just the information that you need to utilize what you already have. So the training outline that you guys have in front of you was kind of designed to start at the beginning with some of the most important things of how the system is put together, and then work through all the way through the how things are communicating, what's happening, when the sorter's running, how we talk up to Vargo. And then also, since all 3 sorters are basically the same, the shipping sorter is a BS25, which is a larger frame sorter. The other 2 sorters, U1 and U2, they're a BS7. And the only difference between the 2 are a 7 can handle 7 kilos per tray, and the shipping sorter can handle 25 kilos. So one's rated for about 15, 16 pounds. The other one's rated for about 55-pound package weight max. But as far as the components, naming, and everything else, they're basically the same. So, to get started with the refresher training outline, the first topic on here is the communication topic. One thing that I don't list on here is the human element of communication. A lot of times operations folks are not as technically inclined as you maintenance guys are. They may see something happen, or they may assume something, or whatever it might be, and they have their own report of what they think. So definitely when you're talking to whoever's reporting an issue, make sure that they're really giving you the right information, the right sorter number, the right conditions, so you can actually drill down to what they're looking at and try to solve the issue. That's the biggest thing. The other point of communication is there's a lot of different types of communication. You have RS-485, TCP/IP, Profibus, serial communication. So what's the difference between like RS-485 and RS-232, and what are the differences on those? Does anybody know? Why would you think that would matter? It's really about the language of the communication. If RS-485 is trying to talk to Ethernet or whatever it might be, it has to be talking the same language. It can't be RS-485 to RS-232 or whatever it might be. RS-485 is just a name of the communication, how it's wired, how it's pinned. It might be 2 wires receive, 2 wires transmit. But whatever that might be, the differences between the communication are still sending the same data. So RS-485 and Profibus, they're almost the same thing. Serial communication, there are many different types. RS-485 is a form of serial communication, and Profibus is too. Profibus is just a different type of communication method. So the bottom line is that all the devices that talk to each other, whether it's RS-485, Profibus, which a lot of the stuff here is serial communication, which a lot of the Aussie devices are. As long as the devices that are talking to each other are talking the same language, then that's the key. So whether it's RS-45, TCP/IP, Profibus, serially, none of that matters as long as each device, no matter what it is, the phone, this laptop, my headset inside that's wireless, as long as they're talking the same language, they can communicate to each other. So that's the key to communication, that and making sure that things are set up correctly. The PLC is basically the same way. You have a PLC in the main cabinet that's sitting down at the other end. You have a cabinet up here on this end, the A11 cabinet and A12, that actually has a remote I/O rack, which is a sub-module of the main PLC. The main PLC is doing all the controls, and all the remote I/O is just talking and reporting data back and forth. There's no device on the sorter other than the inductions, which have their own PLC, but as far as the sorter goes, every photo eye sensor and device on that sorter is just reporting data back via one of these communication methods to the main PLC. And the main PLC is making all the decisions. Each induction has its own PLC. It also has its own discrete network of Profibus nodes, which are basically ET200 serial interface cards, which are I/O modules, and they're just seeing inputs and sending that data back, setting outputs to the motors and the drives and everything. The inductions are actually then connected back to the main PLC via the in-house network here to talk to the main PLC, because the main PLC is still controlling those induction PLCs. That's the master, those are the slaves. Does that make sense so far? So the last point on here is the BES, BDOS, BIOS, BAdmin, BTerm. What do you guys think all that is? Have you had much experience with the Boimer software? Or have you had much experience with it up there? I mean, basically all these things are what we call the BES, the Boimer BES suite of software. So it's just like a Windows, package. You have Windows, you have all these different things that are entailed with Windows. With the BES package, it's a C+ program that's written to run on a Windows machine, and what it does is controls the sorter. In the case here with Vargo is actually making all the sort decisions. The PLC is using all the raw data from the machine, sending that up to the BES server, which is actually deciphering that using some database and spreadsheets, and then it's indicating all these different things on the BIOS and all the different admin tools that we have. The BDOS, that's the database that's behind the scenes working. BAdmin is the user rights that everybody has. It's a program that's in there that IT or like James, I think, or some of the guys can actually set you user rights for different levels of access within the software. But at the end of the day, the whole suite of software that's called BES is just a go-between Vargo and the PLC. So there's not a lot to it. And we'll get more into it when we start looking at the sorter. I'll just try to keep my computer alive. So can anybody tell me, how a PLC is actually working? Like, what is it?
receives an input.
What is the
analyzes
PLC?
it. Ground level logic control.
What is that doing?
It takes inputs, analyzes it, and depending upon the code written, will make a decision to send an output or not.
Okay. So if you think about like a PLC, it's basically, if you look in there in the cabinet, it says CPU on it. So if you compare that to like a laptop, let's say, and the laptop's the same thing. You know, I'm making inputs with keys, and it's making outputs that show up on the screen. You know, I move this around, the mouse, it sees that infrared or whatever's happening here, it moves it around, and basically it's real time making decisions to move that mouse. When I click the mouse, it opens a document. Yeah, so the PLC is doing the same thing. I mean, you have Allen Bradley PLCs, Siemens. I mean, those are the most common that we use, but there's plenty of small, Beckhoff PLCs. There's Modicon. There's all kinds of PLCs out there. But at the end of the day, what they're doing is they're using inputs to analyze data and using code that's written against those inputs to actually set outputs or output bytes, words, double words, integers, whatever it might be, to activate different things out on the machine. So, like if we look at, like for instance, the BIOS for unit sorter 1, this is real time, I'm connected to it out there. I mean, if I hold this over there, when that mouse gets above that element, this is a Visual Basic program that's running on that server. It's using the best software to use the database and the inputs and everything coming from the PLC to activate all this stuff. So basically when I put that there over a chute, it sees the cursor over that chute, and in the software it says what's the status, and it gives me that tooltip text. So it's just using those inputs to set an output to show me that message. Even the color of the chute, it says destination selected. Well, in the actual Visual Basic program, the element for that chute is, it says set it to pink if it's free. If the input at the chute, the jam eye or the full eye is not blocked, so it's set to a 1 because we want the input to be high in case it fails. That feeds all the way from the PLC all the way up into the BESS, and then the BESS would say turn this chute white if it was blocked, if that input was a 0. The same way that anything else works when you press a button or whatever. It's as simple as flipping a light switch on and off. The point is that this is using software to do it. You know, light switch is using a real switch. Like this one over here, it says destination's faulted. That the jam lamp is blocked there. So that inputs a 0 on the PLC. The PLC sends that message up in a message structure up to the BESS. The BESS sees that, says, oh, I need to flash the element in that Visual Basic program that's running, flashing red to be faulted. So that's basically what the PLCs are doing. They're just gathering data and making decisions about everything around them based on the data that they're collecting and what the program says to do. Like when I hold this button down on the computer, which you shouldn't do, after so many seconds it sees that and it says kill it, and that's what happens. If I just press it once, then it's going to go through a shutdown sequence. So really, a laptop and the controls on a sorter are not much different. The thing is that machine out there can process a lot more data. Like the CPUs that are in those inductions and in the sorter are 10 times more powerful, or maybe even more, than what you can get in your standard laptop. somebody turn these lights down maybe so we can see them? There's a lot of glare on the screen from the lights. I'm gonna interrupt your snack time there.
I was eating light, yeah. Got better?
Go from snack time to nap time.
Not like life. Anybody need the light on?
This is actually one of the workstations out by the induction. Try to get over here. So for instance, if I look at the legend here, this is basically everything you see on here for the sorter, inductions, destinations, and emergency stops and trays. All these colors on this chart are all programmed based on the inputs coming from the PLC. The PLC sends that status for everything on the sorter up to the VES, and there's actually a spreadsheet with different statuses and elements that are in the Visual Basic program that actually activate all these different functions within the code. And that's basically how it's working. But the key to the whole thing is the communication. If there's no communication, then how can you troubleshoot anything? And in the case of, let's say the BES crashed or the PLC went into stop, you can see the last thing on here is brown for everything, no communication to PLC. So if I come in here, let's say the sorter was stopped and I went up there and I could see that the whole screen would be brown, then I've lost connection between the PLC and the BES for some reason. Be a network issue because it's not talking back and forth. The PLC could have failed. PLC could be in stop mode. But the biggest thing to emphasize about the communication is if you don't have it, you can't troubleshoot anything. Does that sound like a realistic thing? Or?
Very much. It's happy buddy.
So what questions do you guys have on communication?
What's the, once you lose comms, what's the typical reason? What's the reason that it happens most commonly?
Usually here, I think you guys have power. Is there a demo? That's all right, it's not bad. Usually here, I think you have power issues sometimes, right, with storms and stuff like that.
Yeah.
And the generators are kicking on, and sometimes you might lose communication.
I think we fixed that problem.
Because that was happening a lot at the beginning. But yeah, generally, with a system like this, the BES isn't really working that hard because we're just passing data back and forth from Fargo. A lot of customers typically, they'll download like a massive wave of like orders down to BES, and it's really processing a lot of data. So there's like database issues, especially during peak, where they don't clean the database up, or a lot of customers manage their own servers, so they're just letting like the hard drives fill up with old data until it's just
Scan time's too long.
so then it just locks up the machine. But generally, we don't see too many failures on the hardware PLC wise. I think the main culprit is when people open the doors on the panels and it kills the whole panel and they're not sure how to bring it back up. And of course people get frantic. You open the doors and the whole system shuts down. It's a little bit of the back of your head, a little panic mode goes off. that's the main thing we see on a lot of customer sites. They just rip the doors open without turning that switch, and the whole system's down. Yeah, then they bring it up or they cycle power too many times and the PLC's and stop, and they don't know how to get that, just to take it from run to stop and back on, just to get it to go into run mode. But out of the 450 sorters we have around the country, it's not a very common thing. But it's mainly power. I would say 95% of the time it's a server issue where there's just an overload of data stored somewhere, just bringing the performance down. As far as PLC failures, I would say, and I've never seen a Siemens PLC fail in the last 20 years. So it's pretty robust piece of equipment. Any other questions on communication?
We have each one of these types. I know we have Profibus, but from our I/O cards that goes back to the PLC. That's going to be our. Is that the RS-485? That cable?
From where to where?
From our I/O blocks around the sorter.
Those are just I/O cables.
Okay.
Most of those. From the blocks to the photo eyes and stuff, the cable that's going like between all the blocks, that's called an OSI cable,
Okay.
which is an actuator, sensor, indicator system. That's why it's called OSI. It's pretty simple. But that actually gives, if you look at it closely, the sensors that are up on top of the sorter that are talking to the trays via infrared, they just have one cable because they're pretty low amperage sensors. On the chute boxes, I think they have power and communication. One of those is a black and a yellow cable. But otherwise, between the PLC and all the remote I/O devices, you have Profibus. Every so often, you have a small box with a Profibus module called an OSI module, which is just a module that translates from the Profibus out to those OSI devices, which we'll talk about a little bit later. But you have TCP/IP between the inductions and the main PLC, Profibus between all those devices. RS-485, you have that from the scanners back to the main cabinets. Like both scanners on this sorter, they're over the sorter, they're RS-485, and they actually were plugged into the A03 cabinet all the way at the other end. You would think there'd be one here, but there's not. That cable goes all the way down there. Serial communication, probably on the scanners over on the Cognex, we have those. Yeah, so there's a pretty good mix of communications types. But again, back to what I said at the beginning, it doesn't matter that, like you think about this iPhone, I can turn this on, and as long as it's got the same communication protocol as this laptop, I can connect to the phone. Or I have a Bluetooth headset, I can connect. As long as they're talking the same language, it doesn't matter how it gets there. It could be wirelessly, it could be microwave, whatever it is. As long as they're set up the same communication type and all your baud rates and all those things are set the same, it shouldn't matter. That's just the medium between the devices. Any other questions? So the reason communication is the top thing on the list, because I think that's the most important. Again, if you don't have communication between the devices or the PLC and the BES, then you're going to get nowhere. That's when that goes down, that's the key. That's the first thing that you have to get back up and running. The next thing we'll talk about are the E-stops, safety stops on the sorter. So tell me about the E-stops and what the function of those is. What do you got? What are your perceptions of that?
the system in the event of an emergency, it needs to be stopped manually.
Okay. So when should they be activated?
Well, you're in an emergency. Prevent harm to somebody and.
Okay.
There's an emergency home.
Yeah, so, I mean, the biggest thing is in between e-stop and safety stop. Yeah, an e-stop is a human activated device. And sometimes it's activated when it shouldn't be, just because it's convenient. Safety stops are things on the machine that are designed to protect the machine. So in a sorter like this, there's not a lot of things that could go wrong internally in the system. So we don't have a lot of bells and whistles per se inside the sorter, but we do have other things, that will stop the sorter if there's some sort of an issue. But the e-stop function is basically a hardwired system that goes to every e-stop push button on the system. And we'll actually go through the schematics later, and I'll show you how to trace out the e-stops, because there's a lot of connection points. There's a lot of e-stops. I was here a few months ago, right, James? I mean, we tested every e-stop on this U1 sorter. It took hours to do it because there's so many of them. You don't think there are till you start walking around. But 2 per induction, all the Z boxes, the main cabinets. I think there's some at the scanner tunnels. So we had to check all those. But at the end of the day, the e-stop circuit is a 2-wire loop that goes from a control relay in the main cabinet A02 or A03, whichever one it's in down there, we can look. And those 2 circuits go through the push button on the door down there, the e-stop push button. There's an actual e-stop bypass switch on the door. You've got 2 wires that go through that, and then they go out into the field and go through every e-stop push button around the whole system. Or there's an interlock from that panel to A13, which interlocks the 2 panels together, and then this panel actually has that same circuit for this half of the sorter down here. But at the end of the day, those 2 wires go out, go through all the field devices. The master relay and the panel down here has 2 circuits that go out and do the same thing, go through the door, the switch, out to all the field devices, and then it comes right back into that panel onto the same relay. So technically, if you unhooked those 4 wires, you should have resistance through those as 2 separate loops if the system is closed. And then the panels are interlocked together so that we can report back and forth what's happening and kill both panels with an e-stop. We don't want to kill this panel but have the other one still active down there. But the biggest thing with the e-stops are it's not a sorter function for